In this problem, we're going to solve the triangle. We have triangle DEF here. We use those capital letters at each one of the corners to name the triangle. So that's triangle DEF. We have some lowercase letters here for the sides that we are missing. We don't know how long this side is. We've labeled that side D. We don't know how long this side is, and that is side F. In every triangle, there are 6 different things that we can measure. There are 3 angles, and there are 3 sides. In these problems where the directions are to solve the triangle, they are going to give you 3 measures, and you'll have to find the other 3. In this problem, we know the measure of 2 of our angles. I know that this is a right triangle. This is a 90-degree angle here, and angle F here, that's a 41-degree angle. I also know that this side over here has a length of 28. So those are the 3 things I know. What I need to find is the length of side D, the length of side F, and I need to know the measure of angle D up there in the corner. So we'll need to find angle D, capital D. We'll need to find side D, that's lowercase d, and we'll need to find side F. Those are the 3 things we'll need to find. You can find those using any of the different math tools that we have. You could use trigonometry. You could use sine, cosine, and tangent on that. You could use the Pythagorean theorem. This is a right triangle, so if you wanted to, you could use the Pythagorean theorem if that was appropriate. Or you can just use another property. For instance, the easiest calculation for us to make, the easiest out of these 3 things to find, is angle D, because the 3 angles in a triangle have to add up to 180 degrees, and we know the length of 2 of those. So I can find angle D by doing 180 degrees minus our other 2 angles. And if you do that, you can figure out that angle D is 49 degrees. If we needed to in this problem, we would have rounded that off to 1 decimal place, but that's the exact value. It is just 40, I'm sorry, for angles we would round off to the nearest integer, but we don't have to round because this is the exact value. If we threw it into our calculator and had to do a calculation on it, and we ended up with a decimal, we would round that off to the nearest degree for our angles. For our sides, we are going to round that off to 1 decimal place. Okay. In order for us to find those sides, we need to use an appropriate method. And for that, since we only know one of the sides right now, the only thing we can really do is set up an equation using some trigonometry. So we're going to use SOHCAHTOA for that. We have an angle here. It is a 41-degree angle. And when you look at this 41-degree angle, I have the opposite side that we need to find. That is lowercase f. I have this side here. That's the adjacent side. I'm going to have to find lowercase d. But we do know this one, and that is the hypotenuse. I want to set up an equation that just has 1 variable in it. So I don't want to come up with an equation that has both the d and the f in it, because that's 2 variables. I want to use the hypotenuse and one of these other ones. So I'll just need to decide which one do I want to find first. And I'll just find lowercase d down here on the bottom. So right now what I am looking at is I am looking at coming up with an equation using SOHCAHTOA. I'm going to use my 41-degree angle here, and then I want to try to find the adjacent side, and I know the hypotenuse. So it's the a and the h that we either know or we already, or we're going to try to calculate. So I'm looking for which one of those trig functions with the equations has the a and the h in it, and that is the cosine here. So I'm going to use a cosine equation based on this triangle. The cosine of our angle, which we know, that's 41 degrees, that is equal to adjacent over hypotenuse. The adjacent side we don't know, and the hypotenuse, we know that that has a length of 28. So that's the equation that I need to solve to find lowercase d. We have d divided by 28, so if I multiply both sides by 28, we would have 28 times the cosine of 41 degrees is what d is equal to. We'll throw that into our calculator, round that to 1 decimal place since it is a side length. And if you do that, the calculator will let you know that's very, very close to 21.1. So letter D, we do have a measure for that now. That side length, lowercase d, is 21.1. We have one more calculation that we do need to go through and make. And that calculation is for lowercase f, which is the opposite side here. For this one, you do have a couple of different options. We do know two of the sides now. We know the hypotenuse is 28, and rounded to 1 decimal place, we know the adjacent side is 21.1. And if you know two sides in a right triangle, you could use the Pythagorean theorem to find the missing side. Otherwise, you could also set up another equation using SOHCAHTOA. That's what I'm going to do. So here's our angle 41 degrees. I'm trying to find the opposite side, and I know the hypotenuse, so the O and the H. And if I look at that, that's going to be a sine equation. So I'm going to come up with an equation for this angle, or for this side F, using SOHCAHTOA. The sine of our angle, the sine of 41 degrees, that's equal to the opposite over the hypotenuse, which is F over 28. And if I multiply both sides by 28, then I would know that 28 times the sine of 41 degrees is exactly the length of side F. If you throw that into your calculator and you round that off to 1 decimal place, it is approximately equal to 18.4. So when you go through and solve a triangle, they're going to give you 3 of the parts. You'll need to use SOHCAHTOA, or maybe the Pythagorean theorem, or maybe another geometry property to go through and find the 3 parts that you're missing.